MW2000. Introduction. MW2000 is designed to help learners design and make elements using microstrip linear theory and microwave element design theory with passive element and active element that are most commonly used in microwave bandwidth. Also, learners measure the elements to understand them in various aspects. Learners can combine each element to structure a transmission system and connect to a computer to start microwave-based communication or direct experience of microwave communication system. Communication can be trained by message and file transmitting within the system with computer and provided software program. The FSK method is used for modulation and demodulation, and maximum frequency and transmission speed are 2.4 GHz ISM bandwidth and 14,400 bps. Element training parts can be purchased separately, and students can use provided kits to design and structure their own microwave elements. Hardware installation. MW2000 transmitter. Install a Yagi antenna. Connect RF amp and FSK modular. Connect Yagi antenna and RF amp using an antenna cable. Connect FSK modular and the PC using an RS232C cable. Connect the adapter to 220-volt AC power and a 12-volt DC adapter to FSK modular. Connect FSK modular and RF amp using the power cable A. Hardware installation. MW2000 receiver. Connect Yagi antenna to LNA using an antenna cable. Connect LNA and RF amp using an SMA adapter. Connect RF amp and power divider using an SMA adapter. Connect BPF 2.5 GHz and BPF 2.4 GHz to the power divider using an SMA adapter. Connect two detectors to the SMA adapter using BPF 2.5 GHz and BPF 2.4 GHz. Use two RF cables to connect an FSK Demodulator to two detectors. Use an RS232C cable to connect the FSK Demodulator to the PC. Connect the FSK Demodulator to the RF amp and LNA using the power cable B. Connect the 12-volt DC adapter to the FSK Demodulator. MW2000 demo program. Check whether both the transmitter and the receiver are connected to the PC. Run the PC's MW2000 demo program. The demo program starts. Its window is divided into text receive window, text send, file send receive, host type, serial port, etc. Select Sender under Host Type on the demo program of the transmitting PC. Select COM port from Serial port. Select 9600 BPS from baud. Select No Parity from Parity. Select Receiver under Host Type on the demo program of Receiving PC. Click Connect button on the center right of both the demo programs of transmitting and the receiving PCs. On the Text Send window of transmitting PC, enter text to send. After entering text, press Enter. The Text Receive window of the receiving PC's demo program outputs the received message. Click Find button on File Send Receive window of the receiving PC. Select the file to transfer Open Screen and click Open button. Click Send. The receiving PC opens the Save As window. Enter a new name on the receiving PC and click the Save button. Check whether the receiving PC has successfully saved the file. Simulation, Chapter 7. Prepare AN Soft Designer SV. Run AN Soft Designer program. Select Project under File menu and click Insert Circuit Design. Click None button and a schematic window will appear. Select Circuit under File menu and click Add Substrate Definition in submenu of Add Model Data menu. Enter R04003C on substrate name and select Microstrip for substrate type. In dielectric window, enter 20 for H, 3.38 for ER, 0 for TANM, 0.0021 for TAND, 0 for MSAT, and 0 for MREM. Enter 1.72414 in resistively in metallization window, 0.669 for thickness, and select mil for unit and click OK. Select Circuit under File menu and select Microstrip under TRL and click CPL. Click OK on Select Substrate window. On Microstrip CPL window, enter 1.0665 for W, 0.334206 for S, and 19.3153 for P to set the dimensions. On electrical window, enter 50.7901 for Z0, 15.3928 for K, 90 for E, and 42.78 for ZO, and 60.3 for ZE. On Metallization window, enter copper for metal name and click OK. Simulation structure that is similar to viewable screen can also confirm the screen. To set up the range of frequency, run Add Analysis Setup in Circuit menu. Run Analyze in Circuit menu to start the simulation. Select Circuit menu from File menu and click Report. Graph appears as shown below. Educational outcomes. Students can easily understand microwave communication system and learn microwave system measuring techniques. Students can understand FSK-based modulation and demodulation and the structure of microwave devices. They can also learn to design microstrip lines, microwave elements, and simulation techniques. They can also learn to structure and measure microwave elements.